Hello everyone. Today we are going to see the topic Hadoop. What is Hadoop? Hadoop is an open source framework that is used to store and process big data sets in a distributed and parallel fashion. It was created by Duke Cutting and Mike Cafferla in 2005. Hadoop is used for distributed storage and distributed processing of very large data sets on computer clusters built from commodity hardware. All the Hadoop modules or components are designed with fundamental assumption that hardware failures are common and should be automatically handled by the framework. The core of Apache Hadoop consists of storage part, which is known as Hadoop Distributed File System or HDFS, and processing part, which is MapReduce programming model. Hadoop splits files into large blocks and distributes them across nodes in a cluster. To process the data, Hadoop transfers packaged code for nodes to process in parallel based on the data that each node needs. This approach takes an advantage of data locality where nodes manipulate the data they have access to. Now let us move on to the next topic. Components of Hadoop. Hadoop mainly has three components: HDFS, MapReduce and Yarn. First we have HDFS, which is Hadoop Distributed File System. HDFS is the primary storage system of Hadoop. It's a file system designed to run on commodity hardware. It's a highly fault tolerant and designed to be deployed on low-cost hardware. HDFS holds very large amount of data and provides easier access to store such huge data. Their files are stored across multiple computers. These files are stored redundantly to rescue the system from possible failures. Next we have MapReduce. MapReduce is a programming model and a software framework for distributed storage and processing of large data sets. The MapReduce program runs in a parallel on cluster of machine. The MapReduce framework takes care of the details of splitting the data, running the program's task in parallel, and then collecting the results. Next we have Yarn. Yarn is also known as yet another resource negotiator. It's a framework for job scheduling and cluster resource management. The fundamental idea of Yarn is to split the functionalities of resource management and job scheduling or monitoring into daemons. The idea is to have a global resource manager and peer application. Now let us move on to the next topic. Use cases of Hadoop. Hadoop is used in various industries such as retail, manufacturing, healthcare, financial and energy. First we have retail. Retail companies use Hadoop to analyze customer data such as purchase history, web browsing and social media activities. This helps them to develop targeted marketing campaigns and personalized recommendation. Next we have financial services. Financial service companies use Hadoop to analyze large volumes of data for fraud detection, risk management and investment analysis. Next we have healthcare. Healthcare companies provide Hadoop to analyze patient data, identify patterns in disease outbreaks and improve quality of care. Next we have telecommunication. Telecommunication companies use Hadoop to analyze call records, network data and customer feedback to improve network performance and customer service. Next we have manufacturing. Manufacturing companies use Hadoop to analyze sensor data from equipment and machineries to optimize production and processes and improve the production quality. Next we have energy. Energy companies use Hadoop to analyze data from sensors and meters to optimize energy production and distribution. Now let us move on to the next topic. Advantages of Hadoop. Hadoop has several advantages including scalability, flexibility, cost effectiveness, high performance, open source and ecosystem. First we have scalability. Hadoop can scale to petabytes of data on thousands of nodes. This makes it ideal for organizations with large and growing data sets. Next we have flexibility. Hadoop can handle wide variety of data types including structured, semi-structured and unstructured data. This makes it versatile tool for data analysis. Next we have cost effectiveness. Hadoop is designed to run on commodity hardware, which makes it a cost effective solution for data storing and processing. Next we have high performance. Hadoop can process large data sets quickly and efficiently thanks to its distributed architecture and parallel processing capabilities. Next we have open source. Hadoop is an open source framework, which means it is a free to use and modify. This has led to a large and active community of developers who contributes to its development. Next we have ecosystem. Hadoop has large and growing ecosystem of tools and technologies to extend its capabilities. This includes tools of data ingestion, data processing and data analysis, data visualization. Now let us move on to the next topic, limitations of Hadoop. Hadoop also has several limitations including complexity, security, performance, data quality, compatibility, storage limitations and resource management. First we have complexity. Hadoop can be complex to set up, configure and manage. This can make it challenging for organizations without specialized IT staff. Next we have security. Hadoop has some security limitations such as lack of built-in encryption and access control. This can make it vulnerable to security threats. Next we have performance. Hadoop can be slow for certain types of workloads such as real-time data processing. This because it is designed for batch processing rather than real-time processing. Next we have data quality. Hadoop does not have built-in mechanism for data validation and cleansing. This means that organizations need to use other tools to ensure the quality of their data. Next we have compatibility. Hadoop may not be compatible with all the existing software and hardware infrastructures. This can make it difficult to integrate with existing systems. Next we have storage limitation. HDFS is designed for large files and may not be efficient for storing small files. This can lead to wasted storage space. Next we have resource requirement. Hadoop requires significant hardware resources such as memory and storage. This can make it expensive to deploy and maintain. Now let us move on to the next topic, the future of Hadoop. The future of Hadoop is bright with several trends and developments shaping its evolution. These include cloud adoption integrated with machine learning and AI, streaming data processing, security and governance, containerization and integration with other big data technologies. First we have cloud adoption. Hadoop is increasingly being deployed in cloud, which offers several advantages such as scalability, flexibility and cost effectiveness. Next we have integration with machine learning and AI. Hadoop is being integrated with machine learning and AI platforms such as TensorFlow and PyTorch. This is enabling organizations to use Hadoop for more advanced analytics and predictive modeling. Next we have streaming data processing. Hadoop is being adapted to handle streaming data which is data that generated continuously. This is enabling organizations to use Hadoop for real-time data analysis. Next we have security and governance. Hadoop is being enhanced with security and governance features such as encryption, access control and auditing. This makes it more suitable for organizations with sensitive data. Next we have containerization. Hadoop is being containerized, which makes it easier to deploy and manage. This is also making it more scalable and flexible. Next we have integration with other big data technologies. Hadoop is integrated with other big data technologies such as Apache Spark, Flink and Beam. This enabling organizations to use Hadoop in conjunction with other tools to solve complex problems. Thank you.